Hello everybody, my name is Olaf Molenveld. I'm the co-founder and CEO of Vamp, aka the very awesome microservices platform. And also in the call is Amer. He's product marketing manager from Mesosphere. So in this webinar, we're going to talk about delivering software with less risk and with more fun in an easy and speedier way. So what's actually the problem we are going to solve? The thing is, if you want to increase innovation, you have to lower the cost of failure. It sounds very illogical, but it's a tricky thing to do. It's especially with microservices and containers, continuous delivery, DevOps. There's lots of possibilities, but how to combine these technical solutions like DCOS, load balancers, routers, and make sure that you can do continuous delivery without downtime or performance issue, that's kind of a challenge. And we think with DCOS and Vamp together, we are able to make releasing and upgrading software much easier to do, so there's less risk and less stress, and you can provide better software in less time. So I'm going to skip to the next slide, where we structure this presentation a little bit. So we start off with talking a little bit about what actually are modern applications. Then Amer is going to take over and talk about DCOS a little bit. I'm going to take over and talk about Vamp and where it sits in the DCOS stack. I'm going to talk about what exactly Canary releasing is, what the process is, where Vamp sits in the architecture of DCOS, and then it's fingers crossed, it's demo time. We're going to do a live demo. Hopefully this works. Otherwise we have some backup videos, but I'm quite confident it will work. And then from there, we invite you to ask questions and hopefully start playing around with DCOS and Vamp and investigate all the possibilities there. So I'm going to switch to the next slide about modern applications and DCOS. I'm going to give control to Amer. Hopefully his audio feed is up and running now. Otherwise, I'm going to switch back to me and we're going to move to the slides. Hopefully I can explain it just as good as Amer can, and then move to Vamp. So I'm going to move to modern applications and pass control to Amer.
Problem. So just to make sure that we're on the same page of everyone, I mean, you're probably hearing this all the time. I mean, everyone is trying to solve a lot of problems about releasing new software, and the traditional release process just can't cut it anymore. I mean, traditionally, I mean, I've done this myself. You do some planning, you define the resources you need, you configure these resources, and you start kind of the testing, staging, release, and development cycle, and after that you release it to the customer and get customer feedback. The problem with that is, of course, as we've all been there, it takes a lot of time and effort to go across these cycles, and from planning to building the environment to everything. It just takes a lot of time. So some of the approaches that have come to try to solve the problem is to try to use kind of modern application and a modern application architecture. And kind of the anatomy of the modern application architecture is that it kind of has two big components. The first is microservices, which we're talking about stateless containers, because of you're decomposing your application into small bits and pieces that enables you to kind of easier for you to deploy, to develop, and to maintain. But at the same time, at the back end of these are like big data services. So you're either using a traditional SQL or NoSQL database, to time series, to maybe a search database. And on top of that, you're doing a lot of streaming and batch processing, probably some machine learning, like some of the things like we do when you go to a shopping site and customers like you have to choose X and Y. So this is probably kind of some of the how people are approaching these problems right now. So, and some of the benefit of using modern apps is, as you start seeing that if you have the right platform to support this and the right process, you're probably going to see a lot of difference. First, your release cycle is going to be a lot smaller, so you'll be able to have more iterations, better product. At the same time, you'll be responding happier to customers. How many of us have seen the apps or some of the things we love, and we have seen some of those kind of respond very quickly to our needs, and the other ones not that much, and they just kind of die in the background. And you also have kind of better response to competition. It would be really, really great to have like a no vendor lock-in into the mix. So this is kind of where DCOS comes in. And the DCOS model is not just the model that we invented. It's actually how many large web-scale companies have approached their infrastructure, from Google and Twitter and Facebook. This is how they manage across multiple teams. This is how they manage the huge stream of innovation that is coming. And the key idea here is, instead of having infrastructure that is siloed and serve specific applications like the one on the left, so you have like a bunch of servers for big data analytics, a bunch of servers for containers, a bunch of standard for stateful services, you actually have a single platform that runs across your entire data center on-premise or on the cloud, and then you can use that combined resources for all your applications. And again, you get a lot of efficiency. You simplify your operations because you don't have to manage kind of small snowflakes or small kind of servers. You can scale up and down very, very easily. And it's also easier to experiment, which is kind of the key thing that we want to try. Let's say you want to try a new feature in the new Spark, or you want to try a new service, like you want to add message queuing like Kafka, or any of these services. You can easily add them and easily start from kind of deploying them small to scaling them into production easily, because they have this flexible kind of architecture that is supporting all your applications. And just to give you a little bit of history, so DCOS is kind of built in the shoulder of giants. So again, this work was pioneered at Google with Borg and Omega, and then you got Facebook with their kind of proprietary kind of system. But what happened is, with collaboration between Google and University of California, Berkeley, the Apache Mesos project was born. And the Apache Mesos product is kind of the kernel. Think of it as the kernel and the resource allocator across your data center, which is kind of the beating heart of the system. And Apache Mesos started being deployed at Twitter, and it actually managed to help Twitter scale when it was a tiny startup to some of the big kind of spikes of workload that I've seen, without having any of the veil whales that we have seen, used to be seen in the past. But then what happened is Airbnb, PayPal, and a lot of large organizations started adopting it, and then Mesosphere was born. And the principle of Mesosphere as a company is, how can we make this power accessible to all the people on the enterprise and even on small organizations? So that's why we launched DCOS, and we launched DCOS as the easiest way to put Apache Mesos in production and to get the power of this abstraction in 2015. And in 2016, we also open sourced kind of DCOS, so that kind of becomes easier and easier for customers to deploy. And it currently powers Microsoft Azure Container Service. Big organizations like Adobe, Verizon, Esri, Bloomberg, a lot of these organizations rely on Apache Mesos and DCOS in the running architecture. So it's kind of basically born on the kind of the shoulders of giants, technically, and tested by these giants. And the one final thing, so this is how the world looks like when you have DCOS. So again, one of the common questions is, do you have your own Linux distribution? Do you require your own architecture? Does it run in specific? So one of the beauties of having this level of abstraction is you only require a modern Linux as your foundation, and that modern Linux can be either on physical server, which is kind of basically most of the people use it to get the maximum efficiency, but can you also have it on virtual servers like VMware, or a private cloud like OpenStack, or even on the public cloud, run everywhere. And then on top of that, DCOS runs, and it gives you container orchestration, aggregates the resources, lifecycle management, user interface, and a bunch of security and advanced networking features in the enterprise capability, which is also available if you want it supported from Mesosphere. But on top of that, you've got the universe, which is really what people are looking for as the data center application. So again, you want to run HDFS, you want to run Spark, you want to run Hadoop, Docker containers. A lot of these become like services that run on top, and you can actually use the services and deploy them together, easily scale them up. Makes it very, very easy to run services that took weeks or months to deploy. So this is where kind of DCOS and And this is Vamp comes in, and Vamp comes in as one of the cool services on top of DCS. And I'll leave it to Ola, but it's actually very, very exciting, the stuff that we're working on. And I'll give control back to Olaf to kind of work on this. So give me 1 second.
Yeah, thank you, Amer, for the great words. And of course, Vamp is one of the packages that runs inside the DCOS universe. And we believe it adds a tremendous value to DCOS for developers, for DevOps teams, for continuous delivery. And I'm going to explain and show you why we believe that, that this value is there. So what are we trying to solve? So when you read about all this stuff about containers, microservices, DevOps, continuous delivery, it feels like this should be the reality. Happy Scrum teams, high-fiving, post-its all over the place, and we're releasing often and we're releasing earlier. The thing is, reality is more like this. It's dirty, it's dangerous, it's risky, and when it's, one second, can everybody hear me? Before I continue, I would like to know if people can hear me. Yeah, great. Just one check. Okay, cool. So this is the reality. It's risky, it's dangerous, it's dirty. And when it's risky and dangerous, people tend to avoid these things. So releasing new software, avoiding downtime, avoiding performance issues means that probably the release schedule will slow down. People will try to avoid pushing new software to production as often as is possible with DCOS, containers, microservices. And to make this less risky, less dangerous, and more fun, we created Vamp. Vamp basically is a platform to make Canary releasing and testing and auto-scaling like features easier on top of container schedulers like DCOS. So what exactly is Canary releasing and testing, and what enables it to do? Basically, it enables you to push new versions of your software to production and only expose it to a small percentage of your visitors with specific criteria. Let's say only 5% of your visitors using Chrome coming in from the UK, maybe. And then you can start optimizing and testing if this new version works as expected. If it doesn't work, you remove it out of production again and slide again back to 100% to the old version. If it does work, you gently scale up until you are running a full release. So feature-wise, this enables you to do a few things, which are kind of important. It enables you to do gradual rollouts without having performance issues. You're in control there. You are actually testing in production and optimizing in production without impacting the majority of your visitors. You can do gradual crossovers, so you don't have downtime when you are moving from one version to the other version, or maybe introducing new architecture, new checkout flows, new front ends, maybe even entirely different modernized applications, moving from monoliths to microservices maybe. That's entirely possible with this percentage Canary fading. It enables you to do A/B testing of everything in production, not only content or presentation layers like you maybe are using Visual Website Optimizer or Optimizely for, or Google Analytics experiments, but you can A/B test everything. Search queries, different database backends, different algorithms, environment settings. What will happen if I change this memory setting? Will it perform better in production or not? And of course, you can do this all manual, but we have a RESTful API, we have a command line interface tooling, so you can also automate this, all these features. So you can create processes that are automated, and you can increase velocity and really reduce time to market or increase time to market immensely. So of course, a Canary releasing, we didn't really invent that. It's been done by companies like Facebook, Spotify, Booking.com, Google, of course, Netflix. All the big boys are doing this, and it makes a lot of sense. Basically, if you read this slide from right to left, it's releasing this new version of a software to a percentage of visitors, do the A/B testing in production, see how it works, improve. If it's good enough, you increase, you ramp it up, and then after a while, you have a full release. If it's not good enough, you throw it away. And this is something you do continuously with multiple teams. And you can actually do this in parallel with multiple teams, which is kind of very interesting when you scale up your application architecture. I think the interesting thing of Vamp is that it's pulling together 3 areas, functional areas. One of them is deployment, which is what DCOS is good at, and Docker containers are good at. One of them is routing, which includes load balancing, but it's much more than only simple load balancing, because we talked about percentages and filter conditions. And then we put together big data, because you need to aggregate health metrics, runtime metrics. How is my deployment running? How is my system running? Can I scale up? Do I need to scale down? Do I need to push a new release to production to improve these metrics? And basically, this is what Vamp is. It enables you to run an experiment system on top of DCOS, where you are free to try and play around with new versions of software, A/B testing, gently introducing, playing around, removing if it's not working, without impacting the majority. So you're actually moving away from big bang releases, which is the big fright for every engineer. And you can compare Vamp, I think, with a cruise control or a thermostat, where you have all the different components in place, routers, load balancers, deployment tooling, data aggregators, but you need some smart engine to control it all, to orchestrate, to activate the choreography between all these systems. And of course you can do this. You can build these things yourself using bash scripts, your own little applications, hack it together basically, or maybe abuse your configuration manager like Puppet or Ansible. But we think it's much smarter to have a dedicated layer with a DSL, a REST API, a nice UI to do this stuff, because you want to separate it out of your configuration management, you want to separate it out from your cluster and container manager, and you want to separate it out from your service discovery and your application layer. You want to have it as a separate entity where you control the higher level deployment, scaling features. So where does Vamp sit in these OC layers? If you look from the bottom to the top, we see physical infrastructure, virtual infrastructure, all well known. Then we see operating systems, container engines appear like Docker, Rocket maybe. Then there's scheduling and orchestration tooling, DCOS, Kubernetes, Nomad, Docker Swarm. And then on top of this all, we say layer 7, that's workflow, there's Vamp. So we really focus on the higher level application features and the business features. I think that's important. So lots of tooling around in our space is very much engineer driven. It's very technical, but in the end we want to provide business features. We want to enable the business and engineering to work together and provide better services or features to the customers. And in the end make more money for the company, etc. So that's what we try to do with Vamp. We're talking business features that are actually translated to technical possibilities when talking to the underlying features. So this is a very high level overview of how Vamp works. So we see DCOS here. It's actually managing your container paths, basically. Databases, backend services are often separated because it's still ephemeral infrastructure, so it's tricky to run databases or the common relational databases inside containers. We don't advise that yet. Maybe if you're very adventurous, you can do it. It's often like dependencies outside systems. And then there's your containers that are actually deployed and running and scaling on DCOS. And Vamp sits on the side and it enables these Canary releasing, A/B testing, monitoring, auto-scaling features. And it's not a real-time system. It sits on the side. If Vamp is pulled out, your containers will still run, your load balancers will still run, and Vamp is not necessary for your application to be actively running. It's a non-real-time system that only acts when you need it to act. So this is an overview of our architecture. So Vamp basically consists out of two components. Vamp Core, which is our core application. It's JVM based. We program it in Scala and Akka. You can run it inside a container or as a Java application directly. It has a REST API. It has a command line interface application. It has a nice graphical UI. It uses a data store for persistence. In this case, we use Elasticsearch, but we can use all kinds of data stores to store stuff. And then we have Vamp Gateway Agent, which is a small Go application that runs in high availability mode. So you can spin up a multitude of Vamp Gateway agents on every node of your cluster maybe, or on 3 or 5 or whatever you need. And they pair with a programmable router. In our case, that's HA proxy. So the Vamp Gateway agents program the HA proxy for the routing rules we need it to have. We're using Zookeeper when you're running DCOS, but we can also use etcd or Consul as a distributed key value store. And the Vamp Gateway agents simply sync with the distributed key value store, pick up the routing rules, and start programming the HA proxies to set the correct routing. And Vamp also talks against the container scheduler, in this case DCOS, to deploy and scale the containers the way you like it. And we pull in metrics back in the Vamp Gateway agents, and we store them in Elasticsearch using Logstash, but we also can work with other metric systems like Prometheus or anything that you can think of, Kafka, Cassandra. And then we can use this aggregated data to action upon, like increase percentages of routing, increase scaling, which is auto-scaling. So basically it's a loop that we close, a feedback loop that coordinates these deployment orchestrations, scaling, routing, metric aggregations. So lots of talking about what Vamp adds to DCOS and container stacks, where we sit in the architecture. But of course, it's much more interesting to see this working in real time. So now I'm going to cross my fingers and start doing desktop sharing. And hopefully this all works. I'm going to show you how to install Vamp on DCOS and how to do Canary releases using Vamp. So I'm now sharing my screen with you. If you go to vamp.io, we have a quick start there where you can find all the information about how to install Vamp on DCOS, for example, and how to do your first Canary releases. So I'm going to start installing Vamp on a running DCOS instance. It's running on the Google Cloud. So I'm going to open the DCOS dashboard. Yeah, it's a clean install. We have 3 nodes. Marathon is running. And the first thing we need to do for Vamp to run, we need to install Logstash and Elasticsearch. This is a dependency of Vamp because we need to aggregate and store all the metrics. We created a custom container that has the latest Elasticsearch and a Logstash with a custom configuration, so we can pull in the HA proxy metrics and aggregate them and work with them. So what I'm going to do is copy this JSON and then paste it in the Marathon dashboard. I'm going to switch to Marathon now. So there's no applications running. I'm going to create my first application, which is the Elasticsearch and Logstash container. You see it here. I'm going to create it. It's deploying. And it's running. So I'm going to move back to DCOS dashboard, and then we're going to see if Elasticsearch is up already. Yeah, it's spinning up 3 nodes now. That looks fine. So we have our Elasticsearch cluster running now. It's running in Marathon because we need the Logstash also. So this works fine. Let me check if all the nodes are up. Yeah, they're good to go. So now the next step, which is installing Vamp. We can do the same with Vamp. We can paste the JSON structure into Marathon, but we can also use the DCOS universe packages because Vamp is a package there. So I'm going to switch to the universe screen in DCOS dashboard, scroll down, go to V, and this is where Vamp is. Going to click on install. I have to go to the advanced installation because there's 2 fields I need to enter. The Logstash IP, and I need to have the Elasticsearch URL. So Vamp knows where Logstash is running and where Elasticsearch is running. And then we should be fine. The rest is entered already. It's using Mesos DNS settings as much as it can. But it's using a setting here which makes Vamp install the Vamp gateway agent and HA proxy on every node of our DCOS cluster, which is handy. So I'm going to paste in the Elasticsearch URL. It's this, and the Logstash IP or DNS setting. That's this. We're working on using service discovery a little bit better. So we'll probably in a few weeks' time we're able to do this automatically by using lookups. But for now, I'm going to enter it manually. This is also handy when you already have an Elasticsearch cluster running, by the way. You can point to it and you don't need to spin it up. So everything is set. I'm going to review and install. And it says success. So let me see in my Marathon dashboard, you notice Vamp is being installed, it's running. And when Vamp is running, it will automatically install the Vamp gateway agent on every node of our cluster. In this case, it's 3 nodes. You see them spinning up, and they're running. So Vamp is up, Vamp gateway agents are up. And let me check in the dashboard. Yeah, that's good. So now I have to do some trickery because we didn't enable the service discovery for the Vamp dashboard, and it's still not a DCOS framework. So what I'm going to do is I'm going to check where our Vamp dashboard is running. I notice it's on this machine on .5. This is an internal IP on our Google Cloud. So what I'm going to do is check with my Google console. Go to Compute Engine. I'm going to check what the public IP is of the machine with the .5. It's this one. And the Vamp dashboard is running on 9090. And there it is. So this is our UI. It's talking against the REST API. So hi, I'm Vamp. How are you? This is version 8.085. We're in the middle of releasing 0.9.0, which will also have the beta tag, which means that the API will be more stable. It's talking against the REST API. We're running Elasticsearch for persistence. We're using Zookeeper as our key value store. As I said, it can also be etcd or console. We're using HA proxy as our router. Kibana is enabled, which means that we automatically generate some Kibana dashboards you can look at if you want to create your own dashboards for the Fab metrics. And we're using Marathon as a container driver, which is the default container driver for DCOS. But we also support other container schedulers. So there's two things, blueprints and deployments. Blueprints is the topology that we want to start with, and then when it's deployed, it's a running deployment, and then we start modifying the running deployment. So I'm going to run a blueprint first. So I'm going to go to our guides on the vamp.io website. First, I'm going to go to the first step, deploy my first blueprint. This is an example of a Vamp blueprint. It's fairly typical and standard. It has breeds, those are like artifacts. They are running inside clusters. In this case, we're pointing to a Docker container in the public Docker Hub, which has Sava. It's an example container we run, which is a small monolith inside, website, web server, and some logic. It exposes itself on port 8080 using HTTP. We give it a little bit of scale, and then we tell Vamp to connect port 8080 to the outside world using port 9050. So this is the connection that Vamp can do using the HA proxies. So if I copy this blueprint and then add it to the Vamp UI, again, this graphical user interface just talks to our REST API. So everything we do here, you can do with the command line interface or with your own tooling, like Jenkins or anything. We save this, and now we're going to deploy it. And when we deploy it, two things will happen. Vamp will start talking to Marathon and tells Marathon to deploy this container. And it starts programming HA proxy routing rules. So if I click on the running deployment, I see some metrics. It's green, it's up the container, it's on a server with the IP and a port, and it's exposing itself on 9050. So if I now go to this IP address on 9050, I see a monolith. This is actually running in the container. When I refresh it a few times and go to the Vamp dashboard, you actually see the metrics flowing in. These are metrics that we pull in from HA proxy through Logstash, aggregate them, store them in Elasticsearch, and then we have an event API and a stream, so we can display them. You can create your own Kibana dashboards too if you like to, or your own dashboard on top of the metrics, but this is kind of handy. So now it's a running deployment, and we are talking about immutable infrastructure. So we are going to change the deployment. We don't want downtime, we only want changes and move forward. So let's say I want to scale up. I go into the edit deployment mode. I'm going to find the number of instances. I'm going to change them to 4, maybe give a little bit more CPU, and then save. You can also only post this little part to our REST API with the correct cluster name and service name, and then Vamp will make sure that it's scaling the correct containers. But I can also post the entire blueprint as I do now. So I'm going to save this, and you notice that Vamp now is updating. It's scaling up the number of instances to 4, and it's updating the load balancing rules. So if I go to Marathon, I should see 4 instances running. Yeah, that's nice. And if I go to 9050, I don't see anything different because it's load balanced. So this is the automatic load balancing that Vamp provides. If I go to the Vamp dashboard, you see the metrics. So this works nicely. Of course, it's also resilient. Let's say I'm killing this application in Marathon. I'm doing my own chaos monkey. Destroy this. It's redeploying immediately. So Vamp is in control. Vamp knows there should be 4 instances running, not 0, and it's redeploying. But of course, the IPs and ports have been changed. So Vamp is also automatically updating the HA proxy routing rules. You notice that there's more agents running. So we have more ports. I was working on the 5, but I also have this machine. And if I go to another public IP on port 9050, you see exactly the same. So these Vamp gateway agents and the HA proxies are running on every node of my DCOS cluster. Automatically, when I add new nodes on the cluster, they will install. So everything is automatically exposed and load balanced. Of course, you can configure with edge load balancers and firewalls as needed. So this is the first step. I have been deploying a blueprint. I've been destroying it, and it's spinning itself up back again. It's resilient. There's no Canary release, of course. So let's go to the second part of our tutorial. Let's assume that this container has some bugs, and we created a new one. So Vamp is typically at the receiving end of a deployment pipeline or of a CI pipeline like Jenkins or Circle CI or Worker. These CLI tools or deployment tools will post all kinds of things to Vamp. So, but right now I'm going to do manually through our UI. So there's a new container built. It's in my Docker registry. I want to Canary release to it. So I'm going to add it to my running deployment. That's the immutable infrastructure thing. And then I'm going to tell Vamp I want 50% of my visitors to go to the old one and 50% of my visitors to the new one. And this is basically it. It's that simple. So I'm going to edit my running deployment, simply paste over my configuration, post it to our REST API. Vamp uses event sourcing, so it knows what has changed, what is new. I'm saving it. You will notice that a new container is added, and the number of instances of the old one are back to 1 because that's what it was in my JSON. And now these two versions are running next to each other. I can check, of course. I'm going to Marathon. There's these two containers, 1, 0, 1, 1. And we have this weight percentage. So I can grab the slider, 0%, 100%. I'm going to set it to 50-50. So what happens now? If I go to 90-50, I get a nicely distributed 1, 1, 1, 0. So it's spread 50% between those two versions. This also works independently from the numbers of instances that are running. That's what I mean with business focus. So if I would set the new version to 4 instances, do it. So we have 4 instances running on for the 1.1, 1 for the 1.0. I still have this 50-50 distribution. So when you start auto-scaling, this is very important. It makes a lot of sense to have percentages because that's what your business is used to. So this works nicely. And now I want to scale up to 100%. I can do this in little steps with a workflow gradually or manually. But now I'm grabbing the slider, do manually. It's 100%. Every routing rule is updated. And now I did a full release. 0% to the old version, 100% to the new version. If I go to 90-50, there's only the new version now. So this is a Canary release. If we do support sticky sessions, etc., but for demo purposes, I disabled that because you only see the first version you land on. If there's some error and I want to roll back to the old version, it's still running. I grab the slider and I'll wait a few seconds. I think, yeah, so this is it, 100% to the old version. This is rollback. So it's really immutable, it's moving forward, it's doing parallel dimensions instead of replacing a running version with downtime and issues. So this is a basic example of a Canary release. We do support all kinds of filter conditions. In this example, you see filter condition user agent Chrome, which means that we're sending all visitors using a Chrome browser to this 1.1 version, and the rest will be going to another version. We do support filter strength. In this case, it means everybody that is using Chrome, but if you would set it to 5%, it would say, it would program the routers to pick a random population of 5% out of everybody that's using Chrome and send this to this version. So you can make all kinds of combinations. We do support Boolean expressions, combinations of filter conditions. You can change the filter weight, you can change the filter strength. It's really powerful. And the performance hit is very limited because HAProxy is really in memory super speedy. So that's Canary releasing. We do support a few filter conditions built in our DSL, very common ones like cookies, hostname headers, user agents. But if you are familiar with HAProxy, you can also use straight ACL rules to program the Vamp gateway agents and the HAProxies. So you can go really wild there. This is an example of multiple filter conditions using Chrome and a specific HTTP header, for example. Okay, last part. It's fairly easy to set up different environments with Vamp. In these examples, we use ports, but we also support virtual host names. And in this case, we create a new blueprint, which is more complicated. It has some backend dependencies, which means that the backends will first spin up, and when they're running, we will set environment variables, so the front-end container can connect to the backends, usually the backend services. And it has a different gateway and port, because it can run in parallel with the current version. If I copy this blueprint and paste it to Vamp, I'm going to create a new blueprint, save this one. You see it as a different endpoint, a different port. When I'm deploying this one, the same things happen in Marathon. You see it's deploying a new group of containers, and let's check if it's running. First, you notice the backends are green, and this is the dependencies in the order of spinning up containers. And when the backends are up, the front end will also be proficient. So now the front end is also running and has two backends. It has exposing itself in port 9060. So if I would go to 9060 instead of 9050, I should see a different application. And that's correct. Front end and two backends. So this is a way to manage different environments or microservices or clusters. You can use them together. And the beauty of these endpoints also is those are gateways. So you can change all kinds of stuff inside a deployment, like A/B testing, Canary releasing to new versions, but the endpoint will still be the same. So consumers of it, either DNS mappings or load balancers on the edge that are mapped to this endpoint, or other services that are connecting to it, don't even notice this if things are changing here. They just connect to this endpoint. There's no drop packets when we change stuff, and it's really powerful. So now I've got this different environment running, and it's a little bit strange because it's one front end and two back ends. Now let's say I want to gradually change my architecture, and I want to have one backend, but the backend is changing so much that I need a different front end. So how would I do that with Vamp and Canary releasing? By simply adding a new cluster to the running deployment, merging it basically, but not connecting it. If I would merge this blueprint to the running deployment, which has a new front-end container with a dependency to a new backend container, Vamp will make sure it's added to the running deployment, but it's not patched in. So if I would post this to the running deployment, I need to do it to the correct one. I just post it and then it's merged. And you will notice that a new cluster is added with a new front and new backend. Backend is spun up first, it's a dependency, and then the front end. But you notice 0% weight. So it's not patched in. It's running, but it's not connected for people to reach it. We'll wait a little while, and then it should come up because it's setting environment variables, connection strings. Let me refresh. Murphy's Law, it's still initiating, it's trying to deploy. Let me undeploy the old version, maybe it's a resource thing. So I'm gonna undeploy the 9050 port. And hopefully Marathon can, yeah, it was a resource thing. So now you will see that the front end is also up, the new front end, but it's not patched in, 0%. So if I go to 9060, front end and two backends. That's our current situation. Now, if I want to introduce it with a Canary pattern, simply grab the percentage slider, grab to 50% or something around it. Let's do it nicely. Save it. Vamp is updating the routing rules, no container redeployments. And when I go to 9060, I see a 50-50 distribution of the new front end, which connects to the new back end. And of course, I can do the same. Simply go to 100% and do a full release. Save, and it's a few seconds, and then we're good to go. Yeah, so it's probably some caching thing here. So this is Canary releasing and testing with Vamp. It's very powerful. Of course, there's much more in Vamp. If you go to vamp.io, you can see all the features that we have. I think one of the most interesting, besides Canary releasing, is our service level agreement and escalation, SLA, which is basically auto-scaling, which is very simple. This is the blueprint. We have the breed, which is the deployable to a container. We give it scale. And then in this blueprint, we're going to add SLA, service level agreement. We give it a threshold, upper and lower. We have some built-in types. In this case, it's response time sliding window, which actually aggregates the response time every few milliseconds of a cluster. So it's independent of instances. And then we have some cooling down periods. And then we give it an escalation. So basically what this says, if it's slower than the upper threshold, escalate by 1 until a maximum of 3. So it's auto-scaling horizontally. And when it's speedier than the lower threshold, it's scaling down again. And again, everything is load balanced automatically by Vamp. And there's different escalations. So we have scale instances, which is horizontal scaling. We can do CPU, we can do memory, we can do compositions. All kinds of patterns and escalations in sequence or together can be done over clusters. on instances or on full deployments. It's very powerful, and you can think of all kinds of things to do with this. So here ends my, my demo of Vamp on DCOS. I hope you enjoyed it. I'm going to stop my screen sharing and going to move to the slides. Oh, still sharing, it seems. 1 second. Oh. Okay. Yeah, so that was the demo. I hope my screen sharing is stopped. I'm not sure. I'm gonna see if this. I'm not sure if I'm able to stop the screen sharing. Oh, it stopped. That's good to hear. So this is the demo I did. So I deployed a blueprint on with Vamp on DCOS. I did a Canary release. Then I did a splitting into multiple services and the merging of the services. So I hope I made clear what the power of Vamp is together with DCOS. And if you want more information, you can, of course, download and install DCOS from DCOS.io. Vamp is a package in the DCOS universe, and we have our website, vamp.io, where you can find all the quick starts, all the documentation, API. And if there's any questions, you can use our Q&A environment to ask, and then we can answer them. Yeah, we invite you to participate in this. It's all open source. It's Apache 2.0 licensed. You can play around with it, collaborate, do pull requests. We're very looking forward to any collaborations and hearing what your use cases are and how you think you can use it. So if there's any questions left, please enter them in the Q&A.
Okay, so thanks everyone. So thanks very much for joining us. Again, please feel free to kind of reach out to us. We on kind of the channels, or if you have any questions, you can reach out to us on Slack, chat.mesosphere.com. We have a lot of cool apps on DCS. So this is one of the capabilities of DCS is the extensibility. It allows us to kind of add a lot of these kind of cool applications and systems, and have some of these as the market goes, as the customer goes, or you might want to build some yourself and have it or share it across your company. So DCS provides you that mechanism through the DCS universe. And again, just to recap, you can do a lot of stuff with DCS. You can do container orchestration. You can run Java and Go binaries without even putting them in Docker containers. You can run like stateful data services like Cassandra, message queuing like Kafka, analytics like Spark and HDFS. A lot of these kind of helps you build very, very cool applications on top of DCS and move fast, break things, and build awesome products. So we want to thank everyone for joining us today, and have a good day, everyone. Thank you very much. Bye-bye.